Hello students, how are you all? I hope all of you are doing amazing. So welcome all of you at AriserTalent, and we were discussing about the chapter number 2 of the class 9th chemistry, that is about the is matter around us pure. And in our last lecture we have a discussion about the separation techniques. So until now we have discussed about the separation of solid from solid, and we have discussed the separation of a solid and liquid. Now moving to our next topic, the next category is separation of gases from the air. So today we are continuing with this topic, that how you will separate the gases from the air, as air consists of a variety of the gases. So the today's topic is all about the separation of gases from air. Now, air basically consists of nitrogen, oxygen, argon, carbon dioxide, water vapor. It consists of the variety of the gases. But along with that, air also contains the impurities that cause the pollution, like carbon dioxide, hydrogen sulfide, sulfur gases. There is a variety of the gases present in the atmosphere. Apart from that, that is useful to us. Now, for separating the gases from the air, we have to do basically 3 steps here. So for the separation of the gases from the air, the process is going to be continue in the 3 basic steps. Clear? So the first step we are going to follow is all about purification of air. First step you will do is purification of air. Second one is liquefaction of air. And the last one is fractionating distillation or fractional distillation of air. So these are the 3 major steps we are going to follow in the purification of the air. It means separation of air from the separation of the gases from the air. So the first step we are going to follow is all about purification of the air. As we know that air consists of a lot of the impurities in the form of carbon dioxide, carbon monoxide, sulfur dioxide, and many more gases. Now, what you do in the purification of the air, apart from these gases, some dust particles are also present in the air. So firstly, we will pass this air through a clean water so the dust particles can be removed. So once the dust particles is removed, the purification is further proceeded, and the other impurities can also be removed by passing through the different processes. So what will happen in the first step? Let's continue with the first step, that is about the purification of air. In the process of purification of the air, firstly, we can say that air consists of carbon dioxide, carbon monoxide, sulfur dioxide, and dust particles. So along with these gases, we can see that the dust particles is also going to be present in the air. So for removing these particles, we will pass the air through the clean water. So in this step number 1, you will pass the air in a clean water. As the air is going to pass through the clean water, you can see that if air is passing through the clean water, the dust particle is going to remove from the solution. So if it is passing through the clean water, you can say that dust particles can be removed. So if once the dust particle is removed, the remaining air is going to pass through the caustic soda solution, so the left impurities and remaining impurities can also be removed from that part. So in the third step, what will happen? You have to pass this air through a caustic soda solution. Air is passed through caustic soda solution, so other impurities can be removed. So once if the air is passed through the caustic soda solution, you will get the air that is entirely clean. Now this air is kept, this air is having a moisture, so this moisture is removed by lowering the temperature, and after that you will get the air that is in the form of the somewhat moisture is removed from that air. Okay, so the last step is moisture is removed from air by keeping it at -20°C. So once if you want to remove the dust particles, you have to pass the air through water. Similarly, if you want to remove the other impurities, you have to pass this through the caustic soda solution. And lastly, when the moisture is remaining in the whole system, you have to keep the air at a low temperature. So once the moisture is removed, you can say that now the air is clean. Okay, so these are the three steps basically you have to follow for the purification of the air. Now after purification, the second step is all about the liquefaction of the air. So firstly, copy this part from here. Now the second step we are going to follow is all about the liquefaction of the air. The second step is liquefaction of air. Now what we will do in the liquefaction of the air, we have to draw the experimental setup that how the purification of the air is done. So until now we have seen that the dust particle has been removed, impurities has been removed by passing through the caustic soda solution, and you can see that the moisture has been also removed from the air. So now you are getting the cool air which you have to pass through the system now. So what we will do next, we will draw a schematic representation for this. So this is the inlet pipe. Now, this is the whole diagram which is representing that how the liquefaction step is done. So, what we are going to discuss now, firstly what we will do, this is a chamber in which you are going to pass the hot air in. Air we are obtaining now is removed from the moisture. So, you can see that the air that is obtained by the purification process is passed through this chamber. Clear? So, we will pass the purified air in this chamber. This is our purified air. Now, this purified air, from this is a section for hot air. After this system in which the air is passed is connected through a column which consists of the spiral ring and through which the gases is passed. Now, if you are passing this air, what you have to do, you have to provide an inlet and outlet for the gases. So, for this inlet, the cold air is going to pass from this, and this is an outlet from which the air escapes out. So, you have to pass this system through the spiral tube, so the gases which are hot can be escaped out, and you have to put the cold air in from this inlet. Clear? So, again this chamber consists of the spiral rings. Now, what will happen in this section? In this section, there is an inlet for cold air, and this is the outlet for hot air. So, in this process, you can see that when passing through the spiral, if you are pushing the cold air in and hot air is escaping out, you can liquefy the gases here. Now, liquefaction of the gases basically means lowering the temperature of the gases. If you are lowering the temperature of the gas, you can see that it is very easy to separate them. Now, what will happen in the next case? This air is going to pass through a separator. So, this air from here flows in this section, and this section is nothing but it is known as separator. This is known as separator. When air is going to pass through this separator chamber, you can see that the cold CO2, or we can say dry ice, is removed from this section. So, you can separate the CO2 and dry ice from this section. Now, what will happen? This section is attached to a jet. This is our section which is known as the jet. This is jet. So, this part is known as the jet. When this air is going to pass through this jet, you can see that when the air is living behind this jet, the pressure is very low. The pressure is very low, it means the molecules are very far apart and they need energy to escape out. Okay. So, whenever this air is passed through this jet, the pressure of the air is very low. So, if the pressure is low, it is very simple to liquefy them. If you are liquefying them, then you will pass these air to this fractionating column, which is the third step for the purification. So, this is our fractionating column. And you can see that in this fractionating column, you will get the nitrogen here, you will get the argon here. So, after lowering the temperature, the argon can be filtered out by compressing the air. If you compress the air, you can filter out the argon from here. And if you compress the gases more and more times by lowering the temperature here, you can see that you will get the oxygen here, and oxygen gas is separated separately from this chamber. So, you will get the oxygen in this chamber. So, you can easily separate oxygen from here. Now, what is the fractionating part done here? Our third step is fractionating the gases, and how you will do the fractional distillation. So, this is the third step basically you have, that is fractional distillation of air. So in this fractionating channel or chamber, you can see that what will happen, you will get the gases after passing it from the jet chamber. After the jet chamber, this is our fractionating column, and you can see that we are getting nitrogen, argon and the different gases at the different temperature. So the gases you are obtaining in this fractionating column is at minus 200 degrees Celsius. So you are getting all these gases at minus 200 degrees Celsius, but what you have to do, you have to keep in mind that nitrogen and oxygen will have a different boiling point. So you can have to compress and lower the temperature so you can liquefy or you can get the air from that part. It means you want to obtain the nitrogen and oxygen in the gaseous form, so you have to lower the temperature of these. So for the nitrogen, the boiling point is minus 195 degrees Celsius, and for oxygen it is approximately equal to minus 185 degrees Celsius. So it is the approximate temperature of nitrogen and oxygen, but here you are getting the temperature minus 200 degrees Celsius. So what you have to do, you have to lower the temperature of these gases so you can obtain nitrogen and oxygen in the gaseous form. Now nitrogen can be separated out by lowering the temperature. From this section you are separating the argon. Now the left residue part is only oxygen. So oxygen can be lowered, the temperature of the oxygen can be lowered, and you can separately obtain the oxygen in this chamber. So I hope this fractionating column has been cleared to you. So in the first part, what we have basically done, we have done the purification of the air by removing all the impurities, whether it is carbon dioxide, carbon disulfide, it may be sulfur oxide and many other gases. So these are basically removed by passing it through the water, caustic soda solution, and we have kept the temperature very low by removing the moisture. Now in the second process of the liquefaction of the air, what you have seen, we have passed the purified air from this inlet. In this inlet, it is passed through this chamber. After passing through this chamber, you can see that you have used a chamber which is completely vacuum and you have placed a spiral tube in it. This is chamber which is placed at vacuum. So in this chamber, when the air is passed, there is an inlet for the cold air and you can see that there is an outlet for the hot air. Now this air is going to pass through this chamber, and this chamber is nothing but it is a separator. What is the function of separator? The separator is going to separate the gases. So you can see that the cold CO2 is escaped out from here. So cold CO2 you are getting in the different section. So whole system is now connected to the jet. Why the jet is using here? The jet is we are using here to maintain the pressure. So the air is escaped out with a very high pressure. So whenever the air is passed through it, you can see that the pressure is very low. So if the pressure is low, it means the molecules are very far apart from each other and they will need extra energy to raise up. Okay, so this jet is passing. Up to this jet, you have the only function that is known as the liquefaction. So up to jet, we have performed the function of liquefaction here. Now we are left with the fractional distillation because we want the different airs, different gases in the different forms. So we are passing it to the fractionating column. In the fractionating column, we keep lowering the temperature of the gases. If you keep lowering the temperature of the gases, you will get every gas in the gaseous form. So in this fractionating column, the argon can be separated, and we know that the gases we are obtaining here are at the temperature of minus 200 degrees Celsius. So if I am talking about the nitrogen, it is having a boiling point minus 195 degrees Celsius, and oxygen, it is approximately equal to minus 185. So for obtaining this temperature, you have to lower the temperature here. If you keep lowering the temperature, you will get the different variety of the gases, and the residue only left behind is oxygen only that we are obtaining in the next chamber. So this is how you can separate the gases from the air. So just copy this part from here. So we will move to the next topic, that how will be the city water is supplied. and we are getting the water from water tanks in the cities. How we are obtaining this water, that we are going to deal now. So moving to our next topic, it is all about the city water supply, that how you will get water in your overhead tanks. Now the next topic is all about that you are getting the water in your tanks, then how this water has come from there. So generally when you get a water in your tanks, it is basically coming from river. But river contains a lot of impurities, which is the cause of many diseases. Suppose this river is containing the bacteria and germs, so you will get the typhoid, malaria, dysentery, jaundice and a lot of diseases which is caused due to the water only. Clear? So if the city water supply is passed as it is, then it is not suitable for the drinking and it will definitely going to affect your health. So before passing from the river, the city water supply has to pass through a lot of the stages, so you will get the clean water here. So basically city water supply when done is actually they are performing the 3 steps here. The first one is about the sedimentation. Second step they are performing is about the filtration, and the third process they are doing is removing the germs from that part. It means disinfecting the water. Clear? So this process is actually dependent upon the 3 processes here. So the first process you have is about sedimentation. Second process is filtration. And third process you can say that it is sterilizing, or you can say remove impurities. So these are the 3 basic steps the city water supply has done. So firstly, the water we are getting is actually coming from the rivers. Okay. Then this river water is passed through the pumping station where the process of sedimentation is actually done. Sedimentation means by keeping the water at a particular level so that the heavier impurities will settle down at the bottom part. If the impurities or the big particles settle down, you are left only with the water and the small particles. Now, in the second step, we are performing the second operation, that is known as the filtration. So for the filtration, what you have to do, you have to pass it through the sand, gravel and many more steps so the impurities there are removed. But up to that level, when the impurities are removed, you will not get the water which is fit for drinking. So what you have to do, you have to perform the last step, that is sterilizing. So for sterilizing that part, you generally add chlorine in the water so disinfection can be done and the water is available for drinking to us. Okay, so this is the whole picture which is showing that how the process is going on. So let us see with the help of a diagram that how the process of city water supply has been done. So what will happen in this? Suppose we have a river here. From this river, the water is going to pass through the pumping station. After this pumping station, the water is going to pass through the sedimentation tank. After passing through sedimentation tank, the water is going to pass through sand and gravel bath. After this sand and gravel bath, the water is passed through sand filter. After this sand filter, we will add it to the chlorinated tank. After the process of chlorination, it is going to pass through the overhead tanks at our homes. Okay, so this is the whole chain which is showing that how the city water supply has been done. So for this purpose, you can see that this is a river here. So this part is our river. So from this river, the water is going to pass through the sedimentation tank. This is nothing but this is sedimentation tank. And what is the purpose for this sedimentation tank? After passing the water through this sedimentation tank, you can see that it is actually a process in which the heavier particles will settle down and rest of the particles will get float in the water. So in this process, first process, what you have to do, you have to settle the heavier particles at the bottom. Now, after the sedimentation tank, you can see that water is going to pass through the sand and gravel. So this section is our sand and gravel. So what this sand and gravel does, the sand and gravel is able to remove the rest of the impurities which is present in the water. So the bigger particles you have removed by the sedimentation, the leftover the parts which are very small in size can be removed by sand and gravel, because they are doing the process of second step, that is known as the filtration. After passing through sand and gravel, the filtration process is not still done. We have to pass this through a sand bath. Okay, so after sand and gravel, you have to pass it through the sand bath. So this is basically our pumping station. From pumping station, the water is passed through the sedimentation tank. So make a little correction here. Firstly, the water is passed through pumping station. This is our pumping station. From the pumping station, the water is passed through the sedimentation tank. In the sedimentation tank, the impurities is going to settle at the bottom. After sedimentation tank, the water is passing through sand and gravel. So this is sand and gravel. After this, the water is going to pass through the sand bath. This is our sand bath. So at this section, you will get the water which is free from the process of filtration. So this is our sand bath. After passing through sand and gravel, the water is going to pass through the sand bath. But until now, you will not get the water which is fit for drinking, because we want to obtain the water that is free from all bacteria and germs. So for this, you have to pass the water through the filtration tank, where you can add the bleaching powder and you can add the any of the compound you are using for the purification of the water. And this step is generally known as the sterilizing, because you are sterilizing the solution here. So next step will be this step after filtration will be purification. And this purification is also known as chlorination. What you can say to it? You can say it chlorination, because chlorine is added to the water. And chlorine is basically used to disinfect the water, so you can get the water which is free from germs. Now, after this chlorination step, you will get the water in your overhead tanks, which is situated at the top of your house. So this is your overhead tank. So you can see that for the cleaning of the water, you have to perform the 3 basic steps, that is sedimentation, second one is filtration, and third one is the purification or the chlorination, you can say. So in our today's lecture, we have gone through a discussion about the separation of the gases from air and how the city water supply has been done. Now, this lecture is all over for today. We will deal with physical and chemical changes. That is the last part of our chapter in our next session. Thank you so much and have a nice day.